Are you gonna
I hope that, I want this to show. I hope this will show up on the camera too. All right, you have to look carefully at
What
this.
is that?
I have a cylinder here. Haley's not here, so slide over there just for today, and sit there if you could. I have a cylinder. Turn that back light on so you can see it first. Or front light on, actually. All right. I have a cylinder here that's got a plunger in it. Okay, and inside, if you look carefully, I've got small little pieces of tissue paper. Now I want you to watch this because it's kind of cool. Now you have to turn it off again. All right. Hopefully you can see this on the camera too. You watch. You have to look very carefully. Ready? See that?
What?
Yeah. What?
No way.
Watch again.
Dude, yeah.
Mm-hmm.
One more time.
Now this is not a spark plug. It is simply tissue paper in a cylinder. Okay. It's kind of neat. Here, turn that backlight on now. Put the camera back around. What relationship am I talking about now? We talked about pressure versus volume, right? We talked about volume. What did we do yesterday? Charles' law? Volume versus temperature, right? That was volume temperature. Pressure and temperature. Yeah. Get your notes out. Let's get this going.
Yummy notes. I like that. Watch list. 19th Street.
All right. All right. Now we had so far Boyle's law, which was volume versus pressure.
Correct.
We had Charles' law, which was volume versus temperature. And now I'm going to have Gay-Lussac's law, which is pressure versus temperature. Okay. It's the last way I'm going to relate these three guys together, and then I'm going to put them all together into one equation. All right? And it's pretty easy stuff. I want you to figure out, before I write it down, this time you can, okay? This time you absolutely can. What will the equation look like? Think about what we saw for Boyle's law. Boyle's law was inversely proportional. And Boyle's law looked like this. You don't have to write it down, but V2 P2 equals V1 P1. Got it? Charles' law. V2 over T2 equals V1 over T1. This guy was inversely proportional. This guy was directly proportional. How are these related? What do you think I did to the pressure when I pushed down to the plunger? Increased it. What do you think happened to the temperature? Increased it. So is this a direct or an inverse proportion? Direct. If it's directly proportional, what do you think the equation is going to look like? Who wants to give it to me? Starting with P2. P2 over T2 equals P1 over T1? That's exactly right. Okay. So there's your equation. Now what? We've been doing these for a while now, so up till now I've been doing two period. I'm not going to do two this time because I think by now you understand how to do these. They're not that hard. You simply do them all the same way. I'm just going to do one example on the board, and then I have a quiz / worksheet. It's not really a quiz because you get to use your book, notebook, whatever. And how hard are these? If you were here one day this week, you could do them because you're allowed. The equations are right up here. We've already written your notes. So no one's going to have a hard time with this, but I will grade it. There's things to watch out for are the things I'll point out to you today while I'm doing this example. To watch you don't do it. Make sure you show me all the work and watch for those little mistakes. So copy this guy down, and let's talk about how we want to show the work for this and how we want to do these without making dumb mistakes. Because after this one, you're on your own. And I don't want you working together on this one. Why? Because I want to grade them. So I want to know what you know. I'm in the same too. All right. Now, how do we do these? Same way I did the Boyle's Law one. Same way we did the Charles Law one. Same way we're going to do the lab. By the way, this is double today, right?
No.
Single today? All right, well, same way we're going to do the lab on Monday then for this class. It was, it'll be today for the other class. You're going to write down P1 equals, P2 equals, T1 equals, T2 equals. You got to write that stuff down on the worksheet I'm going to give you. I want to see it picked out of the problem. You need to look carefully and read. P1 means your initial pressure. Okay, what does it say? It says the gas is expanded from this pressure to that pressure. And you know that's a pressure because atmospheres and millimeters of mercury are units of pressure. Okay, so which one's P1? 0.512 atmospheres. Which one's P2? 850 millimeters of mercury. All right, my temperature, my initial temperature, Marie, who is staring off into space. What's my initial temperature?
40 degrees Celsius.
Correct, 40 degrees Celsius. And finally, my T2, it says determine the new temperature. That's your unknown. Now, I have some changes to make here. So the first thing is to pick them out correctly. Second thing, make your metric or whatever changes you have to make. In this case, I got to change my pressures. All right, it doesn't matter which way I change him. If I want to change him to millimeters of mercury, I would do this. Atmospheres at the bottom, millimeters of mercury on the top. 1 atmosphere contains 760. Get your calculators out. You have to help me with this. We're only doing one. And what do you get for that? 512 times 760, God bless you, was what? And rounded to the correct significant figures, what do you get? Katie, what'd you get?
389.
389. Everybody else get that? All right, does that look good? And that's millimeters of mercury. Am I done? No, I still have another change to make here. All my temperatures, whenever I see them, doesn't matter what the other guy is, they have to be in Kelvin. So I'm going to add 273 onto that and get 313, right? Or is it 303? 313. No. Okay. So I make the second thing. I'm going to make my changes as part of this. Next, I'm going to write my equation and rearrange it. Now, I told you, I gave you some hints before. Look who I'm solving for this time. T2. Okay? Now, there's my equation. God bless you. How do you recommend I write this down? What can I do to rearrange this a little bit faster? What could I do? I could just flip them upside down, can't I? Yeah. I could just make it T2 over P2 equals T1 over P1. I just have to flip both of them upside down, both of them. Why does that make it easier? Because now, to rearrange it, all I have to do is multiply both sides by P2. Right? Okay. But if you wanted to cross-multiply, you could have done that. As long as you rearrange it and show me it at the end, where you get your basically your T2 equals T1 P2 over P1. That's all I care about. Now I plug my numbers in. My T1, my initial temperature is 313 Kelvin. My P2 is 850 millimeters of mercury. And my P1 is 389 millimeters of mercury. What do I get when I plug all those guys in there? Him times him divided by him. What'd you get? What'd you get, Hannah?
680.
She got 680. Is that correct? So he got 683. Which is the right number of significant figures? Hannah's right. That guy only has 2. Okay? It's not because 760 only has 2. He's our standard. But that guy only has 2. So 680 would be correct. 4 by what? Kelvin, right? Because millimeters of mercury cancel. Leaves me with 680 Kelvin. That's it. All right. Now, this is, yeah, go ahead.
So do you have to write down the formula with only the variables every time you do?
I have to write down, you have to see, I don't care, if you rearrange it in your head by cross-multiplying or flipping them or whatever you want to do, that's fine. But I want to see the final equation that you used and then the numbers plugged in, both. Okay? So in other words, you don't have to show me all this, although sometimes it's not a bad idea to. But I do need to see the equation rearranged. All right. Good enough. Let me give you the worksheet.